Chapter 9 extra credit video, and we're doing strategies and techniques for testing the series and testing whether it's convergent or divergent. So let's start with a simple one. We have the sum from n equals 1 to infinity of 2 to the n over n squared. So what we could do is we could do the nth term test. So first we have the limit as n approaches infinity of 2 to the n over n squared. This is obviously infinity over infinity. So what we'll do is we'll take the derivative of both the top and the bottom. What'll happen is for the derivative of the top, it's natural log of 2 times 2 to the n over 2n. This is still infinity over infinity, and it's an indeterminate form, so we could still use L'Hopital. Take the derivative of the top and the bottom, we end up with the natural log of 2 squared times 2 to the n over 2. The limit as n approaches infinity of this whole thing is obviously infinity because this top gets really, really large. So because the limit as n approaches infinity does not equal 0, it diverges by the n-term test. Now, we could do this another way. We have a sub n is equal to this, and we could use a root test. So the root test says that if the limit as n approaches infinity of the nth root of the absolute value of n is less than 1, it converges, and if it's greater than 1, it diverges. And if it's equal to 1, it's inconclusive. So what we'll do is we'll take the nth root of 2 to the n over n squared, which is equal to, and this is absolute value, and this is always positive for n is greater than like 1, so we don't really care about that, and we get the limit as n approaches infinity of 2 over n squared over n. So what'll happen is this is, as n approaches, n gets really large, one second. So this is the 2 to the n divided by n over n squared 2 over n. So as n gets really, really large, this number approaches, this becomes limit as n approaches infinity of 2 over n to the 2 over n. And this bottom part will get really, it'll be equal to 2 over n, and then this will be equal to 0, so it's just 2. Since this is greater than 1, it diverges. Let's do another one. We have the sum as n equals infinity, or as n equals 1 to infinity, of n factorial over 10 to the n. So the moment we see this factorial, we're going to use the ratio test. So what'll happen is the ratio test says the limit as n approaches infinity of a sub n plus 1 divided by a sub n. If that is less than 1, it converges. It has the same rules as the root test. So what we'll do is we'll plug it in. Limit as n approaches infinity of a sub n plus 1, which is n plus 1 factorial divided by 10 to the n plus 1, all divided by n factorial divided by 10 to the n. So that is equal to limit as n approaches infinity of n plus 1 factorial divided by n factorial, and then we'll bring this to the top, 10 to the n divided by 10 to the n plus 1. So that's equal to limit as n approaches infinity of n plus 1 times 1 over 10. Now obviously, this will diverge because this will be equal to infinity. There's this 1 over 10 you can bring to the front, but the limit as n approaches infinity of this part right here, n plus 1, is infinity. So this diverges by the ratio test because the limit as n approaches infinity of a sub n plus 1 over a sub n is equal to, like you could say equal to infinity, which is greater than 1. Let's just do one more problem. So if we have the limit, or the sum at n equals 1 to infinity of n plus 1 over 2n plus 1 to the nth power, the moment you see this nth power, well, you just have to realize that it's the root test. So what we'll do is a limit as n approaches infinity of the nth root of the absolute value of n plus 1 over 2n plus 1, all to the power of n. And this is the absolute value. So that's the same thing. And since that's always positive for n is greater than 1, it'll just be these n over n will cancel out, n plus 1 over 2n plus 1. And then this is simply 1/2. And because this is less than 1, it converges. So by root test, because limit as n approaches infinity of the absolute value of a sub n is equal to 1/2, which is less than 1, the series sum as n equals 1 to infinity of n plus 1 over 2n plus 1 to the n converges. Okay, so just to review, make sure that whenever you look at a series, to recognize whichever way is the fastest. So here, when you saw the factorial, you would use the ratio test because the factorials cancel out easily. If you see the nth power, use the root test because that cancels out easily. And then for the part at the beginning, you could easily recognize that because this part gets a lot larger, you could use the nth term test or you could use the root test. So just be careful with what you pick. Thank you.